Hi Chilton 7th graders, welcome to your virtual classroom. Today we're going to be talking about probability, specifically probability with a number cube. So to start with, you can just take a piece of paper. It can be a lined piece of paper, computer paper, whatever you happen to have on hand. And I want you to fold it into fourths. Okay, now once you have it in fourths, see this is the corner right here where all the folds meet. We're going to fold this down like a potato chip, like a tortilla chip, like this. All right, so now when we open up our paper, you have 4 spots with a diamond shape in the middle. I'm going to quickly darken up my lines because it'll help you to see the lines because it's hard to see in the video. You don't have to darken up your lines unless you want to. All right, so in the middle here, we're going to write in probability with a number cube. I'm sure you're all familiar with the number cube. It has 6 sides and the numbers 1 through 6 on each side. Every number is equally as likely to be rolled, so that makes it kind of a cool probability thing to look at. So we're going to start with the problem here. So let's put our problem up in the top left corner. Okay, so Jackson is playing a game with a number cube. He gets a bonus point every time he rolls a 4. Okay, so this is our problem. Before we actually solve our problem and find out how likely it is for him to roll a 4, we're going to look at some other things related to the number cube. First thing is the sample space. Okay, you're probably wondering what a sample space is. I would be if I were you. Okay, a sample space is a list of all the possible outcomes when you roll a number cube. So a sample space is written like this. You have these fancy brackets, and then you're literally writing out all the possible outcomes, all the different things that can be rolled when you roll a number cube. Okay, so a sample space for a number cube looks like this. Now let's talk about the probability of rolling a 4. So let's put our probability down here. What is the likelihood that a 4 will be rolled? Now, for probability, we use this setup. We have a capital P and parentheses. Now, inside the parentheses is our outcome that we're wanting. In this case, Jackson would like to roll a 4. So we're going to put a 4 in here. Now, 4 is one outcome out of 6 possible outcomes. So the probability looks like this. The probability of rolling a 4 is 1/6. Now, the nice thing about probability is it can be represented with a fraction, a decimal, or a percent. So if we were to convert this to a decimal, we would just divide 1 by 6, and we would get approximately 75 hundredths. And if we were to convert this to a percent, it would be 17%. So you have your fraction, decimal, and percent. Okay. Now, the thing you should know about probability is always going to be between 0 and 1 if it's a fraction or decimal. Because it's either 100% chance of it getting rolled, like maybe there are 4s on every side of this number cube, then we would say that this fraction is 1 and the decimal is 1, and the probability would be 100%. If there were no 4s on this number cube, then the probability would be 0. Okay, so all probability when you're looking at fractions and decimals is between 0 and 1. And if you're looking at percents, it's going to be between 0% and 100%. Okay. Now, another way of representing probability is using a probability model. So I'm going to show you what that looks like. Okay, so it's a table basically that lists out all the probability of each different outcome happening. So let me just set up a quick table here. Yours does not need to be perfect. Mine probably won't be perfect, and that's okay. You can freehand this if you'd like. Okay. Okay, so we need 6 small boxes. So 1, 2, 3, 4, 5, 6, and then the rest can be your large box. Okay, so for probability models, we list the outcome on top, and on the bottom we list the probability of that outcome occurring. Okay, so for the case of a number cube, you could roll a 1, 2, 3, 4, 5, or 6. Now, the probability, which we've already discussed over here for the number 4, is going to be the same for all of them, because all of these outcomes are equally likely to happen. Okay, so the probability of rolling a 1 is 1 out of 6 different outcomes. Same thing for a 2. The probability of rolling a 2 is 1 out of 6. 3 is 1 out of 6. 4 is 1 out of 6. 5 is 1 out of 6. And 6 is 1 out of 6. So if you're looking for simple probability, I want to find out the probability that I would roll a 2. Then that would be 1/6. Okay? Now let's add a little something to Jackson's problem here. Let's say that, we'll do part 2 here. Let's say that Jackson needs to roll an odd number to move in the game. Okay, so the first part of this problem was that he needed to roll a 4 to get a bonus point. Now Jackson needs to roll an odd number to make the next move in the game. So let's come back over to our probabilities square and take a look at what the probability of rolling an odd number looks like. First of all, we're going to set it up just like we did here. We're going to have a capital P and parentheses. Now, instead of writing a 4 in there, because we're not talking about the probability of rolling a 4 now, we're talking about the probability of rolling an odd number. So I'm going to put odd in there. Now let's take a look at the number cube. Okay, there's a 1, 3, and 5. So you have 3 different opportunities to roll an odd number out of 6 sides total. So your fraction looks like this. 3 possibilities for odd out of 6 possibilities total. We can reduce our fraction to 1/2. So the probability of rolling a number is 1/2. Now as a decimal, this is 0.5. And as a percent, this is 50%. Okay, so that's what rolling the probability of an odd number would look like. Well, stay tuned. We're going to look at another probability problem, and it's going to be involving socks. See you soon.